In this video, we are back in the note packet on page 5, and we're going to do just a bit more explicit practice with ellipses. Now, as I'm looking at number 2, it's asking me to find the center, vertices, co-vertices, and foci of the ellipse, so similar to what we did in the practice set. But I want you to take a look at this equation. So what's not quite right about this? We've got a plus sign in between our x stuff and our y stuff, but instead of being equal to 1, it is equal to 1,225. The other problem is we have coefficients in front of our parentheses, and we shouldn't have coefficients, we should have fractional denominators. So how can I take care of this problem and my coefficient problem at the same time? We are going to divide the whole expression by 1,225 to get that to be equal to 1 and to get rid of those coefficients. So folks, we know that this is going to be equal to 1. Now, if I want to divide this business by 1,225, we can just divide the coefficients, similar to if I had 2 times 3 over 2. You could cross those off, leaving you at 3. I can simplify the 25 with the 1,225. So 25 divided by 1,225 gives me, yuck. So a reminder that your calculator can turn horrible looking decimals like that back into simplified fractions by using the math enter key sequence. So this allows me to take decimals and turn them into reduced fractions. So math button is right here, and then enter on the 2 fraction, enter again, and that gives me 1/49. So the 1 times the parenthetical stuff, which I do not need, so 1 plus y plus 1 squared, and then our denominator is then going to be the 49. So now this is looking more like ellipse form. So then I can do the same thing with the 49 over 1,225. That gives me 0.04. Math enter, and 1 over 25. So then x minus 2 squared over 25. So there is my equation in standard form. So now I can pull out all the other key pieces that I need in order to be able to graph and to state those key features. So first, let's go ahead and decide on if this is going to be a vertical or a horizontal ellipse. Because my bigger number is underneath the y, this will be vertical. It also tells me that 49 is a squared and that 25 is b squared, which in turn tells me that my a value is 7 and my b value is 5. So we can use these to find our foci and to find the coordinates of the co-vertices and the vertices. So let's go ahead and pull out our center point. This is -2 in the equation, so it's going to be a +2 in our coordinate. This is a +1 in our equation, so it will be a -1 in our coordinate. So my center is at 2, -1. So forward 2, down 1. Boop. C for center. So if this is a vertical ellipse, that means my major axis is going to go up and down. So if my a value is 7, that means I am going to go up 7. 1, 2, 3, 4, 5, 6, 7. For my first vertex, and down 7. 1, 2, 3, 4, 5, 6, 7. For my other vertex. So the coordinates of those vertices would be 2, 6 and 2, -8. And don't forget that my math lab is pretty picky about commas in between your answers. So if you're stating the vertices and it asks you to separate with a comma, make sure that you use that. Then our minor axis is 2b units long. So 5 units to the left of the center, 5 units to the right of the center. 1, 2, 3, 4, 5. Boop. There's a covertex. And then 1, 2, 3, 4, 5. There's another covertex. All right, so we'll see how good I can draw my ellipse. This one's a little bit tough. So again, you just want to make it as round as possible, looking more like an egg and less like a football. Not too terrible. All right, folks, so the coordinates of my covertices, reading them directly from my graph, would be -3, -1, and 7, -1. Now, something that I want you to notice is that my covertices share a y value of -1, just like the y value of our center. Our vertices share an x value of 2, just like the x value of our center. So that's kind of a good way of checking yourself, because the covertices are going to line up with the center, and the vertices will line up with the center as well. And folks, even though this question doesn't ask for it, let's go ahead and state that major axis length, which is 2a, or 14 units long. We could also count it on our graph. So our major axis connects the vertices, our minor axis connects the covertices, and that would have a length of 10 units. So the last thing that we need to find are the foci. So our foci, remember, lie on the major axis, and we need to find them by finding the c values. So c squared equals a squared minus b squared. So c squared equals, our a squared is 49. Our b squared is 25. So 49 minus 25 is 24. So c squared equals 24, square root. So c equals plus or minus. Now, looking at 24, is there a perfect square factor we can take out of that? Yes. We can break that down into square root of 4, which is a perfect square, and square root of 6, which we can then simplify to be plus or minus 2 rad 6. So there's my c value, and for graphing purposes, I'm going to tell you that that is about 4.9. So since this is a vertical ellipse, and since my foci lie on the major axis, we are going to go up 4.9 from the center. So 1, 2, 3, 4.9, almost 5. And then down 4.9 from the center. 1, 2, 3, 4, a little less than 5. So how do we show moving up and down from the center? Since it is vertical, our y value of the center changes. Ooh, changes. So our center is 2, -1. So we are going to go up from the -1, 4.9, and down from -1, 4.9. But writing it in that proper form with the radical, the 2 of the center stays the same. So this is 2 something and 2 something. And then our y value is -1 plus or minus 2 rad 6. And again, we cannot simplify this beyond simplifying the radical, so it stays -1 plus or minus 2 radical 6, and that would be the location of those foci. All right, folks, so we can successfully graph an ellipse and pull out the key features. And just a reminder, your major axis is 2a, and your minor axis is 2b. So folks, this is similar to the problems that we did in the practice set. And again, you don't have to draw a sketch. It is just recommended. So on these problems, we are writing the standard form equation for each of these ellipses that has these key features. So let's start with what we know. On this one, we know that the vertices are at 28 and 0.8. So are those stacked vertically or horizontally? The answer is horizontally. I'm going to go ahead and just sort of do a really rough sketch of this. I'm going to say that this is one vertex at 0, 8, and this is another vertex at 28. So again, just a rough sketch so I can visualize this. So just based on this rough sketch, okay, there we go. Sorry, my phone did something weird there. Just based on this rough sketch, what can we tell about our ellipse? Well, if these are the vertices, that means this is the major axis or the longer axis. So what that means is that this is a horizontal ellipse. And this is useful to us because we know in our equation, we'll have x minus h squared plus y minus k squared equals 1. And since it's horizontal, a squared is going to go underneath our x term. So a squared on the bottom. And that means b squared will be over here. Now, to find out what our center is, we can use that midpoint formula that we talked about in the practice set. And in case you didn't write that down in your notes, that midpoint formula, I'll go ahead and write it above here. Midpoint is x plus x divided by 2 and y plus y divided by 2. So you're just essentially taking the average of the values. So if I want to find the midpoint of my major axis, which will be the center, I take 20 plus 0 divided by 2, which would be 10. I'll just rough it right here. And 8 plus 8 is 16, divided by 2 is 8. So that tells me that my center is at 10, 8. So this is helpful because now in my standard form equation, if it's 10 in the coordinate, it's minus 10 in the equation. And if it is 8 in the coordinate, it's minus 8 in the equation. Equals 1. This is also nice because now that I know the center, we can figure out how far away the vertex is from the center. If I go from 10, 8 down to 0, 8, we have moved 10 units. And if I go from 10, 8 to 28, we have moved 10 units that way. So this tells me that my A value is 10. So since my A value is 10, then 10 squared, or 100, goes in that A squared slot. Now the B value, which is going to come from those co-vertices, we have not found yet. So let's go ahead and look here. Now the co-vertices are going to be stacked up and down from our center. So 10, 0, we'll say is here. And 10, 16, now up here somewhere. So 10, 16, and 10, 0. And there's my minor axis. So again, making our ellipse real. Ooh, a little too pointy over there. That's all right. So looking at how far each co-vertex is from our center, we see that we've gone up 8 and down 8. So this means our B value is 8, which means B squared in the equation will be 64. And ta-da! That is my equation in standard form. So on this one, I only needed to find the equation. We didn't have to find the foci, so I didn't have to do anything with those C values. Now, the next one is a little bit tricky. So what I'd like you to do is pause the video and get as far as you can on your own, and then you can unpause it and we will work through it together. So for this one, my vertices are at -5, 9, and -5, -1. So I'm gonna go ahead and, I think I'm gonna do my diagram down here this time just because it seems a little bit longer. So I'll do my diagram right here-ish. And -5, 9, so 1, 2, 3, 4, 5, and then up 9-ish, we'll just say that's way up here. There's a vertex, and -5, -1, there's another vertex. So that is my major axis connecting those vertices. So what does this tell me about the ellipse? It tells me that this is vertical. And this is important because in my equation, it will be x minus h squared plus y minus k squared equals 1. And since it's vertical, my larger a squared will go underneath my y term. So a squared goes here, and b squared goes under my x stuff. All right, so looking at my vertices, we've got -5, 9, and we've got -5, -1. So my center is going to be the midpoint of my major axis between those vertices. So if I do -5 plus -5, that's -10, divided by 2 is -5. And then 9 plus a -1 is 8, divided by 2 is 4. So my center is at -5. Go ahead and write that over here. -5, 4. And that seems reasonable-ish, even though this is just kind of a sketch. That seems reasonable based on my sketchy graph that I have. So now in my equation, if it's -5 in the coordinate, it's +5 in the equation. Don't forget your squareds. And if it's +4 in the coordinate, then it is -4 in the equation. Equals 1. Now, what we can also tell from this is my a value. So if I go from -5.4 up to -5.9, we have gone up 5 units. Same with if I go from 4 all the way down to -1, that goes down 4 and 1 more, which is down 5. So that tells me that my a value is 5, which means in my equation, a squared will be 25 below my y. Now, the scuzzy thing about this problem is we aren't given the covertices, we are given the foci. So if I plot the foci, -5, 7, so here-ish, there's a foci at -5, 7. And here's the other foci at -5, 1. So what can we use the foci for? How are we going to use the foci to help us figure out our last missing piece or the b value? Well, from our graph, we can figure out our c value. How far do we move from -5.4 to -5.7? We have gone up 3 units. How do we go from -5.4 down to -5.1? Also 3 units. So I'm going to just draw my c value here. That c is equal to 3. So using that expression, c squared equals a squared minus b squared. This time we know our c squared is 3 squared or 9. My a squared we know is 25. And the b squared is what we are looking for. Now, to solve for b squared, let's subtract the 25. Which gives me -16. Now, if this is making you a little bit nervous, like, oh, I'm pretty sure we can't take the square root of a negative because that would give me I. Instead, we aren't going to square root yet. We're going to completely isolate that b squared, which means getting rid of that negative out in front. So b squared equals +16, so square root. And b equals plus or minus 4, meaning for our b value, we're going to go left and right of the center to get our covertices. So if b is 4, then b squared is 16. Woohoo! And we have now written the equation of that ellipse in standard form.